to Jetson AI Labs. It's great to have everybody here. This month's guest is Team Inspiration. They are a team of high school students and most school students from the San Diego area, and they compete in this RoboSub competition where they make an autonomous submarine that uses computer vision and a bunch of different sensors to navigate around and complete different tasks in a pool to essentially act like a big submarine. And it turns out they are the winners of the 2020 RoboSub competition, which is actually like an international and collegiate thing. And even though they were just in high school, they actually won that and defeated a bunch of college teams, which is amazing. So we'll bring them on a little bit, but first, Jim, Dana, and I are going to cover a little bit of news. Dana, Jim, how you guys been?
Doing great. I'm Dana with NVIDIA DLI, which is Deep Learning Institute, and I guess my news is that we are now offering full-day public workshops, not just at GTC, that you can sign up for if you're interested. I believe in July we have accelerated data engineering pipelines. If you scroll down a little bit, we'll see the public workshops. There you go. And fundamentals of accelerated computing with CUDA Python. And in August, brand new course that I've been working on, building conversational AI applications and fundamentals of deep learning. And in September, we have coming up applications for AI for anomaly detection and building transformer-based natural language processing applications, which is just going through a little bit of a refresh to bring it up to date. So.
And you mentioned, Dana, these are actually in person. Was that right?
Well, they are virtual, but they are with a live instructor, with live TAs. Yeah, it's instructor-led. So you can ask whatever questions, you can get help. And so that's a little different than a self-paced system.
Yeah, that's great. I really encourage everyone here to check these out, and having that instructor there to guide you along is really invaluable. And
the lectures are really, some of these are really very good. So, yeah.
Cool. Jim, how have you been? What's going on in your neck of the woods?
I've been well. I'm Jim from JetsonHacks.com. I am not associated with NVIDIA, even though a lot of people say that.
And yet here you are.
And yet here I am.
He is and he isn't. Jim's been around since like the very beginning of Jetson, and JetsonHacks.com is probably the most popular website out there for people that are just going. And even I visit
including
your website,
internal
Jim,
people.
So I have some more videos coming out in July. Our first one is about running your Jetson off a battery. So that seems to be a pretty hot topic. People kind of get confused about how to use batteries. So I thought I'd do a little video on that, and then just some housekeeping videos. And towards the end of the month, I'll have one on LiDARs. LiDARs are really interesting in that people think that the better LiDAR you have, the easier life becomes. And it's almost exactly the opposite of that, because the more data you have to process and all that type of stuff. So I have 3D LiDAR, 2D LiDAR, and just a single point LiDAR, just kind of to give you a balance. I have a solid state LiDAR, one of the Intel RealSense, I think it's L515 LiDARs that we'll take a look at.
Oh, nice. Yeah. I remember years ago when the RP LiDAR first came out, it was one of the first really affordable 2D planar LiDARs. I think it was like $300 or something. And I used that a lot on the Jetson. It was only like 10 hertz and it was just 2D. Jim, what 3D LiDAR are you using?
It's
the Intel one.
Velodyne.
Nice.
So I have a Velodyne Lite, which it's a puck. So it has 16 different lines of resolution. And then there's the solid state one is the Intel RealSense one.
Yeah. And for anybody who doesn't know, the Velodyne puck, it's shaped like a hockey puck. It's circular, and a lot of the self-driving cars and stuff, you'll see them strapped to them, and they're really nice little devices. But yeah, sounds like you've been busy. I look forward to seeing your new videos and checking those out.
And we'll be opening up the Race Car J website here July 6th, right after the holiday. So hopefully we'll start selling autonomous vehicles again.
Oh, that's great. Yeah. So the race car J is correct me if I'm wrong. I think it's a 1/10 scale. Is that right, Jim?
Right. So it's kind of associated with Formula 1/10. So we have a version of that. Then we have a version that is basically the MIT race car, which these are kind of the entry level 2D LiDAR, stereo labs, stereo camera, IMU. We've upgraded everything to be with Jetson Xavier NX as the compute
Sweet.
platform. So they're really kind of the entry level in learning about how actually to program autonomous vehicles at speed.
Yeah. With the Ackerman steering, I think those go like up to 40 miles an hour or something like
Yeah,
really
they'll
fast.
go up to 60 if you look at it incorrectly. But typically you race at probably 20, 25
Okay.
miles an hour.
But they can
Which,
go like highway speeds. That's crazy.
yeah, it's a really interesting thing.
Yeah. So some of you might have seen Jim's videos on the JetBot, which I think I see your little JetBot back there in the background. For those
There
of
he
you who are
is.
unfamiliar, the race car J, the MIT race car, these different RC autonomous race cars, they're kind of like the next step up. And there's a lot of these circuits that you can go to. And I think now that places are opening back up, hopefully that we'll start seeing those in-person races again. A lot of the RC car activity over the past year and a half have been in simulator, because not everybody has a track big enough in their basement or whatnot to test one of these due to the speeds that Jim just mentioned. And generally they'll have them at some event center. I know up in Oakland, Chris Anderson runs a big league up there that people get together and race them, and it's a lot of fun. Okay, cool. And then on my end of things, I don't have too much news. I have one little sneak peek to show you guys a new project that I've been working on. This is some voice capabilities for Jetson. I'll post the link to this in the chat here. This is a GitHub repo for doing speech recognition and different NLP and text-to-speech stuff on the Jetson, and there's a container for it here. This is basically what I would classify as in beta. It's in the dev branch right now of this repo. Let me show it on a little banner here real quick. You can check this out and play around with it. You guys actually, again, are the first people that I've really shown or told about this, aside from a couple other folks that I've been working with. So if you're interested in this kind of thing, you can check this out. It'll do a speech recognition, and then there's different NLP modules that you can run it through. Like this is a intent slot classification for like a virtual assistant. For example, if you ask it, what's the weather in Santa Clara tomorrow morning? It'll say you asked for the weather and you asked for it in Santa Clara and you asked the date was tomorrow morning. So it like automatically parses all of that. And then there's like sentiment classification. There's token classification for telling like different parts of the words, if a word is a name or a word's a place, or different types of tokens. And then the fun one is question answering. You can make like a little chat bot with that. And then there's the text-to-speech stuff there. So if you guys are interested in conversational AI and want to run that on the Jetson, you can check that out and
It's very
give
complete,
it a try.
Dusty.
Well, yeah, it's still like in beta. I've been working on it for this educational course. So Jim Dane and I kind of started doing this whole live stream because of the Jetson AI Fundamentals course that we had put together with the JetBot and Dana's DLI courses and the Hello AI World that I made. And essentially, we've been working to make new parts of that course and make like university course from it as well. And conversational AI, we want to be a part of that. We also are going to have like simulation and other types of robotics in there for robotic manipulation. And I've actually been working on a simulator for JetBot that can run on the Nano as well.
Oh,
so if you don't actually
this is
have
great.
JetBot,
Wow.
yeah. So we've been busy doing stuff this summer that we're
For
excited
your
about.
for your NLP stuff, are you using particular SDKs or libraries?
Yeah, so I use the Nemo SDK to get all the models and train all of that, and exported it from Nemo into Onyx, and then imported it into TensorRT. So it runs very fast. But Nemo basically did most of the work for me. It had all the models in there. I fine-tuned it. So for NLP, the BERT transformer models are very popular, right? And I was using what's called DistillBERT, which is like a smaller BERT that runs faster and less memory, because all of this will even run on the Nano 2 GB. So I was very memory conscious when I was doing this. And DistillBERT's cool because it uses this distillation training process where you start with a BERT model and essentially do transfer learning on that, and through other techniques, this distillation thing, it maintains most of the accuracy of BERT while being like 4 or 5 times faster and using several hundred megabytes less memory. So that's still like under development, but if you guys are interested, you can check that out and give feedback and log issues on the GitHub there. I would appreciate it. Cool. Okay, well, with that, before we get on too far along here, I do want to bring on our guest this month. Again, it's Team Inspiration from San Diego. So let's give them all a warm welcome. We have a lot of people here, so I'll just start adding them to the stream now. Hello, thanks for joining us.
Let's all wave.
Hi. So yeah, you guys are part of the RoboSub competition, and I know that you also done first, and I believe in our discussions from the past, you said you guys have been doing robotics for something like 10 years or something already, which is crazy. And I think you guys are all in high school now, is that right?
That is correct.
Okay, cool. And if you guys just want to go around and introduce yourself, that would be great, and introduce who you are and what you do for the team, what specialties you might have.
All right, so hi, my name is Ashiria, and this past year I was the captain for our RoboSub team, and I also worked on simulation.
My name's Colin. I was the lead mechanical for the team, so designing all the robots and actually fitting them together, as well as I managed the website for the team.
My name's Ish. I'm the electrical lead and also the deputy captain of Team Inspiration.
My name is Mabel. I was the technical paper lead and did a lot of the strategy for our RoboSub team last year. And
hi, my name is Rishi. I'm the software lead and deputy captain.
All right, cool. Thanks, guys. And well, the RoboSub they have on camera there, I think Colin has that behind him. He has a couple streams going. And so yeah, I mentioned before, you guys actually won the 2020 RoboSub competition, which is really blows my mind because that's not a high school competition. That's a collegiate competition. And I know like CMU and Caltech and all those guys entered that too. And it turns out that you came out the top entry, which is really speaks a lot to your background and all of the robotics history you've been doing. And we were talking before the stream, you guys all have internships this summer with different robotics startups, and which is just incredible what you've all done. So with that, I know you guys have some background that you want to present on your RoboSub architecture, and want to show the audience quickly the website. You guys have a really nice website that has a lot of documentation about your project and all the different electrical and mechanical architectures on there and different white papers. So it's really quite professional. And here's the link to it. I'll also post the link in the chat here. But you guys can go there and check out more details throughout the presentation. Okay. So I think, Ashiria, you have a slide deck that you want to bring up a couple things with, if I recall correctly.
Yes.
All right, there we go.
All right, so hello, we're Team Inspiration, and we're a San Diego-based robotics team of middle and high schoolers. We participate in a variety of robotics competitions, but today we'll be talking specifically about RoboSub and a little bit about RobotX. As we already introduced, my name is Ashiria, and today presenting with me we have Colin, Mabel, Rishi, and Ish. So what we'll be going over today, a little bit about our team history and about us, and then about RoboSub, how it worked with the virtual competition these past 2 years, and our competition results, as well as the robot that you can see on the right, which we designed for RoboSub. We'll also be talking about how we use the Jetson Nano for this and how we plan to use the Jetson Xavier AGX, and acknowledge all of our wonderful mentors and sponsors. And we'll also be taking questions throughout the presentation as well as at the end.
So a little bit about our team's history. Some of us started when we were in 3rd grade, so in 2011. We are a community team of 15 middle and high schoolers. Right now, we actually have one teammate that lives all the way in France. We started with the first progression with the Lego robots moving up through FTC and now going on to RoboSub and RobotX. We started competing in RoboSub in 2019. This was a competition that our team head coaches dreamed of us doing even when we were in 3rd grade, and they would always bring us to RoboSub competition every year, and we really enjoyed going to watch, and we couldn't wait to do it for real. So we were very happy when we got to do that.
So did you guys do the first FRC as well?
We built an FRC robot, but we did not compete in FRC because that is very hard to do without a school backing it because of the extreme expense to even get a team registered and competing. So we do have experience building an FRC robot and working with multiple FRC teams for things like outreach.
I see. Yeah, I should have mentioned that you guys are all from different schools around the San Diego area. That's correct, right?
Yes.
Awesome.
Okay, so this is a little bit about RoboSub. RoboSub is an international collegiate level competition where teams from around the world come to Point Loma, which is in San Diego, at this transdeck pool and compete. This competition basically has multiple challenges underwater, such as this gate you can see here that we took an image of in 2019, and multiple robots in the water here. And this competition is also sponsored by the Office of Naval Research to foster new innovation in marine technology.
Could you tell us a little bit about that pool?
Yep, so this pool is used to test Navy material. So yeah, it's quite large, and then yeah, on the edges, it's very curved. So one thing that's actually interesting about that is when we were using sonar, it's supposed to simulate like open water in the ocean. So we weren't actually getting many pings back from our sonar because it was supposed to just bounce off the wall and go off in different directions as it would not come back in the ocean. So it's yeah, it's to simulate or emulate when you put something in the ocean.
Right, it's anechoic, I think that's what they call it. As I recall, it's like 4 times larger than an Olympic-sized pool, and I think it's like 35 or 40 feet deep. So it's not a pool like we think of it. It's more like really big.
Yeah, I posted a link to this in the chat. You guys can check it out, and it seems like all types of people test their AUVs and different types of sensors in here.
So this is actually an in-water test of our sub. This sort of gives you the scale into a little bit smaller pool. We actually have a tether going for remote operations, as this competition we're not allowed to use a tether. So because our Wi-Fi can't penetrate the water, we actually have to make our sub completely autonomous. You can see one of the main differences between an in-water, almost underwater vehicle versus a land vehicle is that now we have that 3rd degree of freedom. So our robot is pitch yawing and then also moving in the XY direction as well. So Yeah, and then you can see the different sort of considerations that we'd have to make. The positioning of our thrusters as well as the penetrators in the back of our enclosure to connect up all the sensors into the electronics. So we'll be going a little bit more in depth about the system throughout this presentation.
Did you guys all build and design this yourselves, or is that something you just bought the whole thing?
Yeah, so we actually used a off-the-shelf RoboSub before this, before constructing our custom one, just to get the idea and get the inspiration from it. But this actual sub was our third custom sub we've built, and we've just been building off of our previous experiences to get to this sub.
Wow,
That's
yeah,
so cool.
I bet that takes a lot. Do you get any leaks or?
Yeah, so we've actually gotten many leaks, and this is sort of how we went to our newest penetrators. So the thing about underwater robotics is that when you pull your sub out of the water, you can actually see rolling water if any water has gotten into your enclosure. So that's something that we got to train our team members to see and catch. Some teams have leak sensors that actually, when they get wet, send out a signal to cut the thrusters and surface, but we haven't had quite that. We haven't been able to implement that technology into our subs yet. So I think, Ashiri, if you wanted to move on, we could highlight the competition.
Yep. So this is showing the criteria for the 2021 competition, as it was virtual because teams, due to COVID, were not able to travel and reach San Diego for the competition. So instead, we submitted a technical paper that was under 10 pages that showcased the novel aspect of our system. We also did 2 skills videos. Ours were about sensor optimization and hull design, both under 11 minutes. This replaced the on-site judging, but also acted as a how-to guide for future teams who want to do RoboSub. And then we have our team website, which basically adds on to both the paper and the videos and puts any details that we weren't able to add in those. So here on the right, we're able to see a diagram of some of the missions that would be in the pool. So we have a gate that we have to pass through, paths that we can follow. These are buoys that you can touch based on the correct image that is printed on the buoys. Bins in which you can drop specific objects, shooting torpedoes through these like plates almost, and then surfacing in this octagon. So our strategy has been to have 2 subs in the water doing the tasks at the same time. So this is a diagram of which sub would go to which tasks based on its capabilities and sensors that it has.
And I think Colin mentioned that you don't have any contact with the sub while it's performing its mission, right? So it's like completely autonomous from start to finish.
Yes. So these are the results from 2020. 2020 was also a virtual competition, and our team placed first overall, second in the video, first in the technical paper, and first in the website. And actually following these requirements that were set by the competition for the technical paper, the video, and the website. That's what we think helped us to win.
Kind of analyzing how our team works a little bit more. Some of the things that help make us successful is, as a high school team, obviously a lot of the college students know a lot more of the technical detail on how to create thrusters or how to do the hydrodynamics, things like that. But for us, our team was mostly trying to focus on make a working product that would focus a lot more on the autonomous aspect instead of the mechanical aspect. Obviously, trying to optimize all the mechanical and the electrical to make the program work as best as it can, because this is an autonomous competition. But our team really focused on the competition guidelines. Those drove our team's requirements. And we did a lot of competitor analysis and research because RoboSub, we publish all of our technical papers every year and team videos every year. So we could look at all the different teams and what they've done in the past. And on the right, you can see one of our trade studies. We put up pictures of what different teams have done throughout the years, and then we ranked all of them based off of what our requirements were. And also just a lot of time and effort goes into making this RoboSub team work, even though we're doing other competitions throughout the year or in school throughout the year. So.
And this slide is sort of touching on what Dusty asked us earlier. Did we use any off-the-shelf sort of robot kits? And we actually use it in our progression, but we actually started with sea perch like robots. So these are PVC robots using bang controls, just sending power to the underwater motors. And then we moved on to a breadboard so we could test our software without having to purchase the entire system beforehand. We moved on to the Blue ROV, and that's a sort of California-based underwater robotics company that really specializes in cheap underwater components. And then we moved on to Orange, which is our 2019 robot. We then moved on to Gray, our 2020 robot, and then we're actually 3D modeling Onyx, our 2021 robot.
So Sea Perch, that, if I recall correctly, Sea Perch is like RoboSub, but for high school competition. Is that right?
That's correct, for middle and high schoolers as well.
Gotcha.
And the fun thing about that, you can see that tether is actually being used so that we don't have to keep the battery of the actual sub within the sub. We can, all the batteries sent through the tether.
Did your team ever actually compete in Sea Perch, or did you just jump straight to RoboSub?
We jumped straight into RoboSub. We wanted to take on that technical challenge and really push our and leverage our competition experiences.
Gotcha.
You people scare me. I'm just going to go straight to the top.
We try not to. But just highlighting our competition time frame, this past year, we actually had 2 weeks of really dedicated and focused time to RoboSub. The season was actually compressed this year, and we had to finish up our finals previously. So to make the most of our time, we actually utilized parallel prototyping, and you can see this on the electronics board where we explored exotic options while also having other team members explore more traditional options. And this, actually, if you go to the next slide, this is continued for our torpedo shooters. So this is actually one of the missions that Asheri was alluding to, where our sub actually can use pneumatics or any other propulsion methods to send out a projectile to go into one of the targets. And you can see 2 different options, either air power or on the right, actually onboard battery and an onboard motor to send the torpedo out.
So you guys like fully model this and make CAD models of everything beforehand?
That's correct. And this is our way of communicating things to the judges without actually building them. And also this allows us to conduct design reviews with our team members to say and get different perspectives to make our models the best way possible before actually even testing.
Yeah, very professional. You guys should just do your own startup. You already got the whole the whole thing down.
Going on to the next slide, we actually extended this same idea for the electronics board, and we just wanted to highlight the tool that we use. And we use Onshape for specifically the electronics board. They enable users to make their own tools using feature scripts, and the global variables were very helpful, as when you changed one variable, it actually changed multiple models around it. So that greatly helped us with our multi sort of board design on the left, and then even also this server rack design using a PCB backplane on the right as well.
So is that like a custom backplane or just the enclosure?
Yeah, so for our backplane this year, the idea was that, or actually our first sub, or third sub Gray, or third or second, I'm forgetting. But Gray, the main issue we had with it was wire management. It was a mess. If we did do a layer stack design, as we showed in our previous slide for gray, which has a smaller enclosure, but it's kind of useless because if you have wires going in between the plates, you can't pull out any of the layers and troubleshoot or do any maintenance. So to fix this, what we did is we custom designed a PCB backplane, which sits in the back, and each layer has another PCB attached to it. And all the wires are localized within the board itself, within each individual layer. So now there's no crisscrossing wires going in between. The PCB backplane handles all the wire routing, power distribution, as well as we can localize generic components like USB hubs and like Ethernet switches. And we could put those directly in the PCB backplane. So we don't need to use up that space elsewhere in the enclosure. This pretty much allows for, in that animation, you can see you can pull out each board just like that and access it just by itself. So it kind of took that server slot inspiration and stuck it onto our sub.
Yeah, to give the audience some background, backplanes are essentially like a motherboard for these line replaceable modules that you commonly see these in like higher end embedded systems where they're like server rack mount almost, and you can just plug them right in and all of the connections are routed over that. So where did you guys learn to do the PCB design and layout and bring up and all of that?
Most of it I learned one of our mentors. He has a lot of experience in Qualcomm as an electrical engineer, and now he's also started up he's actually who I'm interning for. He started his own internship, startup called Tiny Vision, where I'm interning for, and he's taught me a lot about PCB design, as well as some of our mentors from Northrop Grumman, and also just a lot of self-learning.
Wow, that's awesome. Yeah, it's always something that I wish I got into, and I know a lot of folks from the Jetson community. They've like made their own boards and own little hats and servo sensor interfaces and things like that. So, is one of these modules, is the Jetson mounted to that? I think you guys are using the Nano.
We can actually see that nice large sort of rectangular prism on the back, and that's a representation of the Xavier. So this is our actually next iteration of our sub, and we wanted to make it a little bit utilize a beefier sort of processor. So that's actually representing the Xavier. Our Nano is actually on our previous subs.
Awesome. Okay. Yeah. I mean, if you can power and fit the AGX Xavier in there, that's the top of the line performance. That's awesome. How do you cool this thing? Is it cool just because it's underwater, or is it conduction cooled, or does it just not run that long so it's not an issue?
So with our previous subs and with the Nano, we actually don't have cooling. So we're just doing 20-minute sprints, but actually not pictured here. We're mocking up an actual heat sink that would attach to our end cap. So our end cap previously, you could see in the video, had all the penetrators through, and because that's aluminum and have contact with the water, we can actually extend that sort of metal to maybe touch the heat sink of the Xavier to cool it down.
Did he get disconnected? I don't see him anymore.
Oh, yeah. Sorry. He dropped off. Colin, are you back?
I am back. Thank you so much. Wrong shortcut.
Yeah. No problem.
Let's not click Control W anymore. But anyway, moving on to our materials evolution. This is sort of highlighting the difference between subsurface and actually land vehicles. So our 3D printed components actually took a beating from the sun. The heat within the enclosure, you can see our electronics board actually bent due to all the heat within there. And obviously breaking off from sort of the small inconsistencies within the 3D print. So we've actually since then moved on to laser cutting and then also reaching out to sponsors to use multi-jet fusion. So a little bit more expensive, more robust 3D printing manufacturing method.
How long does it take you to 3D print these?
Yeah, so actually our previous print with all of the correct settings, it took us 24 hours to print 3 components of our enclosure clamp. So Ashia, if you could actually go on to the next slide, you can sort of see some of, or actually next slide after that, pardon. You can see this is the enclosure clamp that I'm talking about. So this is actually 4 components all slotting or fitting together. And 3 of these pieces actually took a full 24 hours because we had to print it with 30% infill and ensure 3 walls. So we're slowly increasing our print settings for even more durable components. And then sort of backtracking, we used actually strain analysis to see potential breakpoints within our 3D printed parts. And you can see a lot of the hinges and a lot of the sort of corners where planes intersect took a lot of the force from the actually compression of the enclosure tubes.
What tool did you use to do this analysis?
We use Fusion 360.
So just as Colin talked about our iteration and evolution of the actual sub, we also worked a lot with making our tools better. Before we started off with an off-the-shelf, well, I guess to go back, in the very beginning, we mentioned leaks when it comes to our enclosure. In order to prevent these, the best way to go at it is use a vacuum pump, see if there's any air leaks. So you pretty much form a vacuum inside the enclosure and you see a gauge. And if the gauge shows that the pressure is increasing, which means there's an air leak somewhere, that also probably means you'll have a water leak in that same spot. So before we had a standard off-the-shelf vacuum pump, and that was handheld and it took a lot of effort. And after a while, it actually wasn't accurate anymore and we couldn't rely on it. So then we took it into our own hands and we custom designed our own electric vacuum pump using a standard motor, which I think can go to -20 kPa, something like that. So that does the job as far as vacuum testing goes. You just turn it on and leave it, and you can let it do its thing while you're doing other things. So that both saved us time and also a lot of handheld laborious work, which was really useful, especially when your hand got sore after doing it for like 15 to 20 minutes of just pumping that enclosure. Another thing was we changed our penetrators this year. Before we had these standard epoxy-based penetrators. Pretty much it's like, think of a tube and you stick the wire through it from the outside cable, and then you just fill up the remaining space with epoxy. You pot it and it would work, but then sometimes you would have these little air bubbles or air gaps, which aren't normally visible to the eye. And you can see in that picture, the paper towels are damp, which means that water got in somewhere. And there's no way of figuring out where it got in because all these holes are too tiny to locate. And even though the vacuum test was showing that air was leaking out, we couldn't identify from where because it was a small amount, but enough that it's potentially dangerous. That water, if we leave the sub in the water for 20 minutes, enough water could get in and damage our components. So then we changed our connectors to these wet connects. These are 2 individual pieces, one localized directly within the end cap. That's the big middle picture. That has the pins, it's multi-pin, and it's sealed together with an O-ring. So now you don't have to pot anything and there's no more human error involved. And then on the other end, you have your other connectors directly soldered and attached to the other end of the cable of either the thrusters or sensors on the outside. So this also helped a lot with maintenance because we had an issue where some of the motors weren't working and we weren't sure where the issue was. We could just plug in different motor cables into different ends on the enclosure caps, and we could see if the same motor is working on different ports or not.
So is it mostly the motor controls that are going in and out?
Motor controls, sensors like sonar and things like that. We also have a DVL, which we added on, a Doppler velocity log. This is pretty much a really expensive yet precise way of finding the velocity of our sub, which is really important when it comes to navigational accuracy and path planning and things like that.
Interesting. Is your camera inside the enclosure or is it outside?
We have it on the inside. We're using a low light camera, which plugs in directly into our Jetson interface. It's a USB camera. We have one facing forward and we have one facing the bottom. For the bottom, there's a track and we can track that tape or I forgot what it's called.
Cool. So is there like an actual name for these connectors? I know like in past life I would work with mil spec systems and they would be like 38999 connectors or they just go by this name, wet connectors.
These are, they just go, the type of connector is a wet connect, but they aren't, there's this Blue Trail Engineering. That's where we got these connectors from. He specializes in creating components for these. The end caps which we use are from Blue Robotics. They aren't custom CNC'd or water jet because that's really expensive and not really for us. So we can buy those, and then these connectors are special fit exactly for those holes in the end caps.
Gotcha. Yeah, everything seems very specialized for this underwater environment. And in Jetson, we see a lot of like IP67 systems up to IP68 or mil spec systems, but even those are not specialized enough for this underwater environment. So it's really interesting, all of the things that you got to go through in order to do that.
All right, and this is a personal project which I've also been the hydrophone lead. Hydrophones in this challenge are pretty important because one of the tasks is there's pingers along the pool. There's 3 different pingers and each are at a different frequency, beeping about every 2 seconds at 25, 30, and 35 kilohertz. So above human hearing range, but below standard for hydrophones, it's within the range of standard hydrophones. So you can see in our version 1 model, we had a more simple filtering mechanism where pretty much it was just the filter. Everything else was off board, and it was just to test to see if the concept would work. If we wanted to localize all of our filtering on a hardware solution without doing like fast Fourier transforms on a software solution, which could be pretty taxing for a processor, especially if you need to do real-time stuff like this. So the first version, we just had a simple filter. I don't even think it was an active filter. In our version 2 design, we put in an active filter as well as putting amp inside it and some other digital components such as a digital potentiometer, which would handle adjustable gain. So we could see how loud, if we wanted to increase or decrease the volume of the hydrophone signal. In version 2.1, I think I also added in another filter at the very end of the circuitry as to isolate any noise that was introduced during it. So this would make for a really clear signal. So you could hear exactly what frequency you want. I forgot to mention there's a digital frequency selector in there. So pretty much the Jetson can tell this board, I want to listen to 35 kilohertz and you will only get 35 kilohertz. And then it can do whatever algorithms later on to identify where the sound's coming from.
So how many of these hydrophones do you have on the system? Is it just one or is it an array?
So we only have 3 hydrophones located in an equilateral triangle around our sub. An array would probably be a lot more precise, but it also bumps up the cost quite a lot. So what we do is with the 3 hydrophones, we're able to locate a heading, as well as possibly if we use phase signal analysis, we can use locate the direction, or not the direction, the distance the pinger is from the sub. But as of right now, we can only determine the heading of the specific pinger we're looking for.
So in terms of how these are actually used in the competition scenario, you were referring to these pingers. Are they
Mhm.
other objects floating around in the pool that are emitting sounds that you're trying to track? Is that
Yeah,
the gist of it?
that
Cool.
more or less. So these pingers are placed near other missions, like for instance, I think there's a pinger next to the torpedo mission, and I guess in that scale picture we showed in the beginning, you can't really see how far away these missions are from each other. They can't, when you're at one mission, your camera, nothing can see where the other mission is for the most part because it's pretty far away. So you use the sound system and you can locate where the next mission is and navigate to there.
So this is essentially passive sonar?
I guess sort of.
Okay. Yeah, I don't know too much about it, but it strikes me as you're not actively pinging and then listening for the
No,
returns. Okay.
no. And if we move on to the next slide, you can see this is this is what I've been working on lately. If you on my camera, I have one of the daughter boards right here, which I've designed. So 3 of these would plug into our main motherboard on just for the hydrophone subsystem. All of our power distribution is localized entirely within it. And each daughter board contains the filtering circuit respective for each hydrophone, each with its own gain adjuster, whatever frequency selector you want. And pretty much all of these signals would go into a teensy, which considering I'm guessing most of the viewers on the stream are developers, you probably know what an Arduino is. A teensy is pretty much an Arduino, but on steroids. It features a ARM Cortex M7, 700 megahertz processing speed, and you can even overclock it to about a gigahertz, which is really good for something really small form factor. A teensy for scale is about the size of an Arduino Nano, so it's pretty impressive. So that's I guess the large array of pins you see on the top left of the motherboard, which is the leftmost board. So starting out, we of course started with the Raspberry Pi because it was what we were familiar with, and that was what was included in the Blue ROV2. And then as we moved on, we realized we needed more. There were more requirements for a new processor if we wanted to do well in the competition. So we went to a Nano to be able to handle the CV, and it was also rather affordable and small, so it fitted our needs pretty perfectly. As we went on, you can see we used the Jetson Nano in orange and gray, which were both pretty satisfactory, but we knew that we wanted to do more things like stereoscopic vision and perhaps LiDAR and things like that, and we would need more stuff. So we have some tasks listed in the one more slide. Yeah, so we needed to switch. We chose the Xavier AGX because, of course, more sensors means more resources required. We needed sensor fusion, robot localization, dynamic path planning, and of course, artificial intelligence, which the tensor cores in the Xavier AGX are really useful for. We also had a larger enclosure space available now due to us increasing from a 12-inch to 18-inch long enclosure. And we were also planning on putting in that heatsink, which Colin mentioned earlier. This is just some specs comparing the Nano to the AGX, and you can see it's a pretty major increase, especially when it comes to that clock speed and the 4 more cores, and also that RAM. The RAM is that jump from another 8 gigs, and also it's now 256-bit, super important. And when it comes to training AI and using it, and also when it comes for our CV computer vision stuff, just a lot better. And also that 16x PCI slot, future expandability. We can get a lot from there if we want to put whatever we want.
So can you comment on like what computer vision processing you're running, or what machine learning, what actual libraries have you used on the Jetson to process the camera and the other sensors, and what does your whole processing pipeline look like there?
I think our main expert on our OpenCV and machine learning stuff, she's not here right now, but I know
Sheahen can talk about it.
yeah, Sheahen can talk about it some as well.
Yeah, so what we mainly used is we're running OpenCV on the Jetson, and basically it's doing it's applying a bunch of filters that are able to look at the image, and then basically the stuff underwater is like the colors are very different than the water. So the water is like green, but the gate and stuff will be like bright orange. So we're able to filter based on color, and then apply filters to like smoothen it out, and then find coordinates of where those missions are.
Gotcha. Okay. And I think I recall seeing some cool block diagrams on your guys' website. So I encourage folks on the stream again to check out Team Inspiration's website here. They got some really great documentation and white papers on there about how they actually went about architecting this system and putting it together.
Yeah, watching this presentation, I'm kind of getting the feeling how those people got their heads handed to them in the competition. This has been excellent.
Yeah, you guys are very organized. And I think you use ROS as well. Is that right?
Yes, we do. And in fact, actually, we use ROS because we have a lot of different processes in our software system that kind of do different tasks. And in order to have them all communicate with each other and pass data, we found that ROS is probably the best solution for that type of thing. So yeah, as you can see on this slide, this slide is kind of weird. I think an image accidentally got put on top of another image, but anyway, it's fine. On the very left, you can see a group of processes, and those are the AUV localization processes. So the goal of each one of these is to increase the robot's understanding of its state and its environment and where it is in the pool. So for localization, there is a process that takes DBL data and it integrates all the velocities, and from that we can actually get the position. And then obviously for perception, there's a bunch of different computer vision programs. Each program is specific to the different missions that are in the pool, or like some of the missions will just be determining the position of different objects, while other missions are actually differentiating between different images. So then different techniques are applied based on what's needed. Or then, again, going back to localization, there's, like Ish mentioned, there's a hydrophone signal processing process. So the hydrophones go to a TNC, and the custom PCBs, that does all the signal processing, and that's sent to the Jetson, and so on and so forth. We have all these sensors, but we know we can't rely on any one of these sensors exclusively. So what we do is we have this voting process, and so that basically just rules out basic inconsistencies between different sensors. So for example, in the main mission execution loop, let's say, as a very simple example, let's say an object in computer vision, in the computer vision frame, is actually drifting, like it's moving laterally. But the robot is supposed to be going forwards. It's supposed to not be drifting. And the IMU is also reporting that, or the accelerometer on the IMU is actually also reporting that the robot is not drifting. Then you know there's an inconsistency between at least one of those sensors, and that at least one of those sensors is reporting something wrong. And so the voting processes are kind of there to make comparisons between different sensors and determine which sensors are the most likely to be correct. So that is currently in development, and we plan to iterate upon that and make it better. And we also use libraries for sensor fusion in terms of just pure localization instead of perception, kind of fusing multiple sources of data to make sure that the robot's understanding of where it is in the pool is accurate and not like made incorrect by some false data. So like different filters that are applied to the sensors. And then there's a mission planner that takes this state data and determines what mission it wants to do next. And actually, the mission planner uses multiple different factors to decide what missions it's doing next. So like what missions have been done in the past, the probability of completing future missions, the amount of time it takes to complete future missions. And actually, in our competition, we use multiple subs, and those subs communicate using modems. So one sub will actually notify the other sub of its status and what missions it has completed. And then those subs will coordinate and dynamically update the list of missions that need to be done based on what the other sub has done. And so the mission planner then, after dictating what missions are to be done, it moves into mission execution. And that's where the actual mission is completed. So you have like a list of possible states that the robot can be in, and then a list of possible actions to get from one to the other to complete the mission. And lastly, we have a flight controller. So we can't just like turn on the thrusters and expect it to go straight or like move smoothly or hold its depth, because obviously there's a lot of different extraneous forces like random currents, buoyancy, all that. So to compensate for that, we just send high-level movement commands, like where we want to move, to a dedicated flight controller. And that flight controller then makes the according adjustments based on sensor data to actually move smoothly. Right now, we have been using the Pixhawk, but we actually do have plans to develop a custom board and program it to serve all the intended functions. So we have plans to develop a custom flight controller in the future. So that's an overview of our software system and how we coordinate everything.
So couple questions. You mentioned that the subs actually can intercommunicate during the mission, and they have some modem. What type of interface works underwater? What are they communicating over?
Mabel or Ish, do you want to talk about that?
Can you ask the question one more time?
Rishi mentioned there's a modem that allows your two subs to communicate together. What is that works underwater?
So it's an acoustic modem. This one was actually off the shelf. It's called an M64 modem. It's sold by Waterlinked, I believe. The way it works is it sends out, well, through acoustics, of course, it sends out a variety of, I guess it's a black box, but we can assume it sends out a variety of signals through sound throughout the pool. It's supposed to be omnidirectional, or at least horizontally. And I guess the main caveat with underwater communication comes in the fact that it's extremely slow. Even when buying these off-the-shelf products, which are specialized for it, it's only at about, I believe, 8 bytes per second. So it's like sending an 8-letter word every second. So it's really minimal, and that's where you learn that it's really important to be concise with whatever you're sending.
That's slower than satellite. I know work with a couple other customers in the past, developers that were making these autonomous ocean-faring craft, not submarines, and they were using like Iridium or other satellite connectivity, and it was much faster than that, expensive, but not 8 bytes per second. So I take it's basically just sending a couple bytes when it like achieves a mission state or something like that. You're not really sending much information at all over it.
Yeah, it's mostly just like status and telemetry and things like that. Really really high level things. Nothing too long, just the overall idea of what's happening to the other sub.
Still, that's really interesting. And so Rishi, we're talking a lot about the localization. And do you have a map of the pool beforehand that you're localizing against? Or is this just like a global world model that you're building dynamically over the course of the mission?
So actually, in the actual competition, they allow teams to kind of go there early, and then over the course of like a couple of days, they allow teams to kind of collect data on the pool, and they can build a map if they choose. Our goal is to kind of not like rely on that as little as possible. We do like note down the different locations of the missions, but overall we kind of aim to rely more on our perception capabilities in order to have this sub like once it's in the general vicinity of said missions, position itself relative to the object and use its perception capabilities to complete the mission without relying too much on pre-recorded data. And that kind of becomes more important later on. In the finals, they change the pool from being in quadrants to they split it in 2 parts, and they rearrange all the missions accordingly. And you don't have any sort of data on that. So your sub does have to be completely autonomous and more intelligent to kind of survive that situation.
Gotcha. Yeah, no, that's really cool. And you know, when we talk about autonomous on ground vehicles, a lot of times they have the ability to phone home. You can retask them, but this is exceptional, and like it really is operating out there on its own. So one more question for you. We briefly talked about how you're using ROS. So is each of these different boxes essentially a different ROS node, or how have you implemented that in ROS?
So yeah, for the most part, the small boxes are kind of the ROS nodes. So like as you can see, or on the very left, those are actual physical hardware devices. So DVL camera, hydrophones, sonar. But then you can see like localized during the DVL, that's a program that's connected to the ROS network. And then all those programs are basically just sending the sensor data or the process sensor data over the ROS network. And then there is a voting program, the mission planner, the mission scheduler, execution, whatever, that those are on ROS. And then the arrows are kind of like publishing and subscribing to the different topics.
This is all pretty cool. Looks like we're kind of running out of time, but I think we need to know maybe what you're doing next, right? And maybe Mabel, I think, had something to say about that.
Yeah, so our team actually recently got awarded a boat for RobotX. So RobotX is basically the next level past RoboSub. It used to be a RoboSub and your boat working together. But as you can see, this year is going, or this competition season is going to be a drone working together with a boat. And at the bottom of the slide, you can see some of the mission diagrams. It's going to be a lot of computer vision, a lot of machine learning, trying to cooperate together to work around all these missions. It's going to be in Sydney, Australia, in November of 2022. This is not completely open water. It's going to be in a bay, but the same challenges still apply. And we are looking for teammates to join, as well as a lot of subject matter experts to help support all of us while we are taking on this new endeavor.
Awesome. And I know we kind of ran out of time here, but and I know you have like the simulator. If you want to show the video of that real quick, I know the audience would be interested because this whole sim to real thing is real big. So you guys have built a really cool underwater simulator.
Yeah, so this is sort of a promotional thing from CAD to simulation into the actual sub. So this is actually can be found on our website. Sheahen, if you maybe progress up 2 slides. Yeah, computer vision. This is actually our strategy for this year because we didn't get our most recent sub into the water. We only got one of our subs. We're actually testing computer vision on the simulator. And this just allows us to get the test data and almost identify what to expect before we put our sub into the water.
Awesome. It looks really, really good.
One more slide. If you, this is one of the screenshot of a live feed on our Twitch channel. And you can actually see our simulator moving, or pardon, our sub moving throughout the pool throughout the week, and we'll be upgrading it throughout the coming month to more accurately demonstrate the vehicle capability.
Yeah, and this is actually for the one that is streaming on our Twitch channel. It's powered by an NVIDIA GPU. So using the thousands of cores that we're able to process simultaneously, it allows the simulation to look more realistic and process like the simulated sensors and the environment better and faster. So, and then we're streaming that on Twitch so that people around the world can look at it and yeah, see it moving live, as Colin mentioned.
All right. Thank you guys so much. I know you guys are very busy and you just had a big competition over the weekend through all this, and you'll have internships now. So thank you for taking time out of your busy schedule to join the live stream here and share all the great work that you've been doing. And I wish you the best of luck in the robotics and your 2021 RoboSub competition. And it's just really incredible all the stuff that you guys have done and all the technology you're using in these things.
It is very inspirational.
That was way excellent. I liked your presentation.
Yes, thank you.
Thanks.
All right,
Everybody wave.
With that, we're going to sign off. We'll see you next time. Thank you.
Thank you.